Right gang, welcome to another dynamics video. We're going to have a look at a variety of different things that we've covered over the past few videos or few sessions in solving this problem. So as we can see here, we've got some kind of lifting equipment carrying a load of 750 kilograms. It moves through a distance of 10.5 meters at a speed of 1.2 meters per second. It's got a frictional resistance to motion of 250 newtons. Determine, and we've got 5 different areas we're going to cover here. First thing, the time taken. Next, total lifting force, work done, and then we've got 2 power calculations to work our way through here. So slightly different and slightly more complex than what we've done so far, but nonetheless relatively straightforward. So first things first, we're going to get our information and we're going to lay it out nice and neat. Alright, but I do that, and you might want to draw a little table or make a little list, but what we're actually going to be sort of looking at is making that list of these known values. So we've got load 750 kilograms here, that's our mass. Alright, don't forget your units, and if you missed any videos up to this point and you need to go back, we've got a distance 10.5, and we're using the letter S to represent this distance or displacement. We've got velocity, suspension is speed here, but the more familiar we are with the word phrase velocity, the easier it'll be to solve these problems. And we've got frictional resistance of 250 newtons, which is what this force is here. Okay, so first things first, we're going to have a little think about how do we calculate time if we've got distance and velocity. So if we come back to our bog standard velocity equals distance divided by time calculation, what we can then do is we can rearrange this. And if you've missed any stuff on rearranging, get yourself back in and watch the videos in relation to that, so you can get a little bit of practice. So we've got distance divided by velocity. So the distance taken from our list is 10.5 divided by our velocity, which is 1.2. And you can pop that in your calculator. And we'll get an answer of 8.75 seconds. Okay, so we've got time taken there. Next thing, total lifting force. And this is when it becomes a little bit more complicated than what we've done already. The total lifting force, force total, is equal to the mass times the acceleration plus the force that's needed to overcome resistance to movement. So we've got 2 bits of information we need to add to find this total force here. Now the acceleration that we've got our mass here, we've got 750. The acceleration that we've got is the acceleration due to gravity, and as you'll remember, and it's on your formula sheets, that value is 9.81. So we'll stick some brackets around that just to make sure I'm doing that as a separate calculation, and we're going to add the frictional resistance force to that, and that's a value of 250 newtons. So the total force, I'll let you guys work that one out. The total force we've got 7.6 times 10 to the 3. I'll put a 0 on that one. 7.60 times 10 to the 3 newtons. Double check that. Yeah, 7,600 something. Okay, next one, work done. So now we've got our force, we can find our work done calculation. We've got work done equals force times distance, which is equal to the force, so it's the total force I'm looking for this time, 7.60 times 10 to the 3 times the distance, which is 10.5, and we've got a value, again pop that in your calculator. We'll get an answer of 79.875 times 10 to the 3 units for that one, joules. Okay, now if you do 3 significant figures or 1 decimal place, obviously that would round up, but we'll leave it as that just now because it might make some of our further on calculations a bit more accurate. Okay. Next bit, we've got power. power is equal to, and we're talking average power here, work done divided by time. So the reason we're having to do these in this specific order is to calculate power we need work, and we've got to do work to get that. We need force, and to get that we're going to pop in 79.875 times 10 to the 3, and we're going to divide that by the time taken. So it's 8.75. Don't forget to be double checking these. So we'll have 9,129 watts. Watts. Okay, so we've got the answers to these two. The first 4 questions there. Last bit, power dissipated and overcoming friction. So to get an object to move, you've got to overcome friction. Alright, check out the coefficient of friction video if you struggle with that one, or alternatively get back into your notes. So we've got the same formula, power equals work divided by time, but the work here is the work that's used to overcome friction. So this is going to look slightly different than before. So the work to overcome friction is this one. So it's going to be 250 newtons times the distance, which is 10.5. Don't forget, work is force times distance. I'm going to divide that by the time, so we've got 8.75. You know, it's going to equal 300 watts. Alright, so you can see there's a massive difference between the power required to keep this object moving than there is the power to get it to actually move. Alright, so there's various things going on there. We're going back into our dynamics, working our way through various bits and pieces. Now, again, the only way we're going to get good at this is if we practice and practice. So, next slide here, and I've shown you these before, but if you can solve these questions, then you'll be doing very well. They get more and more complicated as they work their way through. Questions 1 to 5, pretty straightforward. Questions 6 to 10, a little bit trickier. So, as always, thanks for watching, and if in doubt, give me a shout and I'll try and help you as much as I can. All the best, bye bye.